All right, today we're going to go over binomial theorem, section 5. All right, so there are several theorems and strategies that are going to allow us to expand binomials raised to a power, such as x plus 4, quantity to the fourth, or 2x minus 5y to the seventh. And one of these theorems is using Pascal's triangle. Do you remember Pascal's triangle, where the first row is just a 1, and then the second row is a 1 with a 1? So every row from here on out was going to start and end with a 1. And then how you get the other numbers is you add the two numbers that are diagonally above that spot. So for well, this is technically row 0, row 1. This next row would be row 2, technically. And you'll see why in a minute. But the first one is a 1, and then the next guys you would add 1 plus 1 will give you 2, and then it ends with a 1. And then the next row would be a 1, and then a 3, and then a 2 plus 1 is also 3, and then it ends with a 1. Next row starts with a 1. Next term would be 1 plus 3 would give you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4, and then 1. All right, your turn. Fill out the next row. Hopefully you got a 1, a 5, a 10, a 10, a 5, and a 1. Do it again. Do the next row, which is technically the 6th row. And hopefully you got 1, 6, 15, 20, 15, 6, and 1. And we can continue like this forever. It does get cumbersome, right? It gets to be a pain in the butt. Like, I don't want to regenerate this many rows of Pascal's triangle if I have to go to the 15th row. Forget it. I've got another way to do it though. So when they're just short ones, so what it turns out is when these guys get expanded, these are the Pascal's triangle represents the coefficients on each of your terms. And so that's why this guy is called row 0, because anything to the 0 power would just be 1. This is row 1, because if it was x plus y to the power of 1, it would be 1x plus 1y. This is row 2, because it goes 1x squared plus 2xy plus 1y squared. The row will match up with the exponent up here. So when you go to do x plus y to the fourth, you're going to use row 4 of Pascal's triangle, the one that starts with a 1, and then the next one is a 4 for the coefficients. All right, so Pascal's triangle is wonderful, but when you need too many of them, it's too much. So we also have factorials. Do you remember how 5 factorial is not me shouting at you excitedly, 5? No, it's 5 times 4 times 3 times 2 times 1. And any number factorial, n factorial, would be n, and then times n minus 1 times n minus 2, all the way down until you get to 2 times 1. And then if you remember from last year, choose notation, NCR, n choose R is that notation, and it's n factorial over n minus R factorial, R factorial. And it can also be written as this, where they put these parentheses and they put n on top, r on the bottom. This is not a divided by, it's just the notation. And it's just, these two mean the exact same thing. It's just another way to write it that's kind of simpler. So let's find the lie and fix it. Put those in your calculator. 10 factorial divided by 10. This is 10 choose 6. This is 16 choose 11. Put those in your calculator. And hopefully you found this one is true. Second one. Oh, do you know where the choose notation is on your calculator? I know not to bother showing you my calculator because it won't show up. But PRB. You'll see the PRB button, and then you'll see NPR, that was permutations, and then NCR. So you can just, if you're going to do 10 choose 6, you would hit the 10 first, 10, and then PRB, arrow to the right for NCR, hit enter, and then 6. And I got 210. You also can use this formula of, okay, this means 10 factorial divided by 10 minus 6 would be 4 factorial and then 6 factorial. And that factorial button is also under PRB on your calculator. So hopefully you found that one's true. That one was not. That one you should have gotten 4,368. So it turns out there's a connection between all of these NCR numbers and Pascal's triangle. Kind of spoke that. Take, for instance, row 4 is 14641. It turns out that if you do 4 choose 0, you're going to get 1. If you choose 4 choose 1, you're going to get 4. 4 choose 2 is going to give you 6. 4 choose 3 will give you 4, and 4 choose 4 will give you 1. And so it totally matches up with these guys. Will match up with Pascal's triangle. Isn't that lovely? And so this is actually going to help us expand binomials, as well as just find one particular term in the expansion without expanding the whole thing. So we're going to use this fact, and more what I end up showing is this guy here, the n factorial over n minus r factorial, but the choose notation will work out the same way. All right, let's do let me show you the steps on how to expand a binomial, a plus b to the nth power. First of all, you'll get the coefficients. You can use Pascal's triangle, and if it's a low degree exponent, if n is small, I would just use Pascal's triangle because it's pretty easy to generate. But if it's not, if it's a larger exponent, then we're going to use this choose notation instead. And then do you remember, we did this last year, powers of each of the variables. The powers on the first term descend. So the powers on A will start with a to the n, and then they'll go down. They'll go all the way down until it's a to the 0 power. The powers on the second term on B are going to start with b to the 0 and go all the way up to n. All right, so that's what we're going to do. We got the coefficients and then the powers on each of these variables, on these terms, and we can expand it. All right, so let's expand x plus y to the power of 4. Start with your coefficients. This would be the 4th row of Pascal's triangle, which means it would be a 1, and then a 4, and then a 6, and then a 4, and then a 1. Notice I left space here for my terms that I'm going to raise them to exponents, and I put plus signs in between each of them. All right, the powers on the first term descend. So we are going to start with an x to the power of 4. The next term will be x to the power of 3. Next term will be x to the power of 2. Next term will be x to the power of 1. And the last term will be x to the power of 0. The second term, y, is going to start with y to the power of 0 and then increase as it goes up. So y to the power of 1. The next term has y squared. The next one has y cubed, and the last one will have y to the 4th. And then, of course, you simplify. Anything to the 0 power is just a 1. So this first term simplifies as just x to the 4th. You don't need to include the 1 on the power on the y anymore. I don't need to include this one on the x anymore. And 1 and x to the 0 is just 1. So this guy is an x to the 4th plus 4x cubed times y plus 6x squared times y squared plus 4x times y cubed, and then plus y to the 4th. There's your expansion. Lovely. All right, now, they're not always this simple, right? I think the next example is, what if it's just not just an x and a y? What if there's a 2x and a 5y or something like that? All right, so we're going to do a 2x and a minus y squared to the 5th. So the original pattern is what follows the binomial pattern, but then you'll have to simplify, right? So we'll start with the original pattern. And it's a 5 as this outer exponent. So I'll just use Pascal's triangle because it's easy. We're going to use the 5th row where it starts with a 1, and then the next term is a 5, and then it's a 10, and then it's a 10 again, and then it's a 5, which I ran out of room here, so I brought it down to the second line, so a plus 5, and then the last one will be a 1. So those are my coefficients on the original expansion of just the binomial expansion. All right, now this time it's a 2x, and that's your first term, and you'll start with 2x to the power of 5 on the first term, and then it's a 2x to the power of 4. Notice there's parentheses around these guys. That's important because the 2 and the x have the 5 on it. So we'll be doing 2 to the 5th and x to the 5th. Yeah, okay. So then it's a 2x to the 3rd, and then a 2x squared, and then a 2x to the 1, and then a 2x to the 0. I've got a minus sign here too. So it's not just y squared. I'm going to do a minus, a negative y squared. It's not that the, notice there's not parentheses around this negative. So it's your second term is a minus y squared, and then to the power. All right, so we've got negative y squared to the 0. Next one will be negative y squared to the power of 1. So that squared is on the y, not on the minus sign. But then parentheses around it, now that 1 is on the whole thing, and this 2 is on the negative and on the y squared. All right, then a minus y squared cubed, a minus y squared to the 4th, and then a minus y squared to the 5th. And then we simplify. Yeah, that 0 power, that's just a 1. 2x to the 5th would be 32x to the 5th. Here, I'll have a minus sign here to the power of 1. We'll keep that minus sign, so it'll change signs. It'll be a minus. It'll be y squared. 2 to the 4th is 16, and then 16 times 5 will give you 80. So we got minus 80 x to the 4th, y squared. Third term, this squared is going to make that negative a positive, but y squared squared will be y to the 4th. 2 cubed is 8, and then x cubed. So times 10 gives you a plus 80x cubed, y to the 4th. This next guy, the negative, but then cubed, so it'll be a negative sign out front. Y squared to the 3rd will be y to the 6th. 2 squared will be 4, and then times x squared, so it'll be a minus 40x squared times y to the 6th. This guy, the negative will be positive now when you raise it to the 4th power. Y squared to the 4th will be y to the 8th, and then times 2 and 5 and x gives you a 10x y to the 8th. Last but not least, to the 0 power, that's just a 1. So you got 1 times negative to the 5th power will be a negative, and then y squared to the 5th is y to the 10th. So you got a minus y to the 10th. And there you go. So notice the binomial pattern happens with the expansion, but then in the final answer, no, we don't have all of these, it doesn't follow the pattern anymore because of this squared, and we had the 2 that we were multiplying and stuff. So it's just the original expansion. All right, now we're not going to expand the whole thing. We're just going to find something specific in the expansion. So we're going to find the coefficient of the indicated term and identify the missing exponent. All right, so on the term that has x to some power y to the 9th in the expansion of x plus y to the 11th, that would be a pain, right? We could do it, but we would want to do that, right? So here's what we know. In the expansion, like this didn't have any exponents on it, in the expansion, these 2 exponents will add up to 11. So each of the set of powers on the normal regular expansion will add up to the 11. And so the question mark, right, the exponent on x plus 9 will be 11, which makes the exponent on x will be a 2. So I've got x squared, y to the 9th will be the variables. Now I need to find the coefficient. We're going to use that n choose r. It turns out that it will always be n choose r. It'll be 11, so 11 factorial over, do you see that the 2 and the 9 are, one of them is 11 minus 9 and the other one is 9? It's the n minus r and then r. And it doesn't matter which one you choose. 11 choose 9 or 11 choose 2. It'll give you the same answer. And so it's 11 factorial over 2 factorial, 9 factorial, which when you put that in your calculator, you can either do 11 choose 2 or 11 choose 9, or if you are putting that in your calculator using the factorial, you better put parentheses around these bottom guys. Let your calculator know you're dividing by both 2 factorial and 9 factorial. All right, so my answer is 55x squared y to the 9th. All right, how about find the term involving b to the 6th in the expansion of a minus b to the 14th. All right, so I know I've got a to some power and negative b to some power, but we want the one that has b to the sixth. So if I want b to the sixth, and I know that this exponent plus 6 is going to equal 14, that makes it to the eighth. And then your coefficient will be 14 factorial over 8 factorial, 6 factorial. It matches these exponents here. And so that ends up giving you, this will end up giving you 3003, and then a to the eighth. This negative to the sixth power is a positive now, so just b to the sixth. Had it been an odd number like 5, then your answer would have been negative. All right, how about we just find the third term in this expansion? So not all of them, just the third. So what you want to do first is figure out what are the exponents on each of these terms. The third term on a would have been an a squared, right? Because the first term would have been an a to the fourth. Second term would have been a cubed. Third term would have been a squared. So hopefully that makes sense. So we got an a squared on the first term. On 5b, because our exponents need to add up to 4, then there's a 2 on that guy. And then my coefficient will be 4 factorial divided by 2 factorial, 2 factorial. And 2 factorial is not the same as 4 factorial. Hopefully you remember that. All right, so we've got, this ends up being a 6, a squared, 5 squared is 25, and then b squared, and then 6 times 25 will give you 150, a squared, b squared. How about the fourth term of, ooh, more complicated. Okay, so fourth term. Keep in mind the 2a would have been first to the 11th, right? Then to the 10th. Obviously it's a 2a, but I'm just trying to shorten it real quick. And then the third term would have been to the 9th, and then the fourth term would have been to the 8th. So we've got the first term 2a to the power of 8, and then our second term is a negative 6b. And if 8 and this guy need to add to 11, then this box is a 3. And then your coefficient will be 11 factorial divided by 8 factorial, 3 factorial. Don't forget that it's 2 to the 8th and a to the 8th. It's a negative 6 to the third. That's an odd power, so it will become negative. All right, so 11 factorial over 8 factorial, 3 factorial, you should get 165. 2 to the 8th is 256, and then times a to the 8th. Negative 6 cubed is 216 with a negative since it was an odd power, and then b cubed. And then you'll multiply 165 times 256 times negative 216 to get negative 9,123,840 times a to the 8th, b to the third. All right. Hopefully all of that made sense. This is your homework. And yeah, if it didn't make sense, come see me in office hours and I can answer your questions. Alrighty. You all have a fantabulous